Welcome to This Explainer. Look, if you've ever been jolted awake at 3 a.m. by a blaring pager because a system just suddenly crashed, you absolutely know the pain of bad scaling. It's the worst. Today, we're completely ditching the guesswork. We're going to dive into how true architects actually plan for capacity with absolute precision. Let's get right into it.
Here is our roadmap for today. We'll be walking through the exact chronological journey an architect takes, so we'll cover the capacity planning mindset, calculating core resources, database sizing, the golden planning formula, a real-world architecture case, and finally, what an architect's true job actually is.
Section 1. The capacity planning mindset. Now, there is a massive contrast in how people handle slow systems. The typical amateur reaction, total panic. They just throw hardware at the problem. Add more CPU, double the memory, spin up extra servers. But enterprise architecture doesn't work like that at all. If you underplan, your whole system overloads, right? But if you overplan, you are literally just setting money on fire. The professional enterprise reality is highly calculated. It's this strict, non-negotiable combination of current demand, hard data, future prediction, and a very precise safety margin. Capacity planning is never a guessing game.
Moving to Section 2. Calculating core system resources.
Let's ground this in reality, shall we? An architect's very first step is actually never looking at a CPU or a spec sheet. It's looking directly at the business. Take this enterprise scenario. We've got a network management system supporting 100,000 total users with 10,000 on concurrently. We're hitting peak requests of about 2,000 per second. And on top of all that, we're monitoring 20,000 routers, pulling data every 5 minutes. But here's the real kicker, the strict service level agreements, our SLAs. Our API has to respond in under 300 milliseconds. That is literally the blink of an eye. And critical alarms, they cannot be delayed by more than 5 seconds, period. These strict business rules dictate absolutely everything else we're going to do.
But before we do any math, we have to figure out what's actually eating our compute and memory. Think of these as the silent resource killers. Where's it all going? Well, it goes into the heavy lifting, things like the API computation itself, the relentless JSON parsing, real-time data encryption and decryption, complex SQL queries, and critical OS page caching. Every single request is just chipping away at those resources.
So the crucial point here is applying simple, undeniable math to those business metrics. If we take our 2,000 requests per second, and let's say we know each request takes roughly 10 milliseconds of CPU time, boom, that immediately gives us a raw baseline of 20 CPU cores. But remember that enterprise mindset we talked about? We don't just stop there. We bake in a 50% buffer for safety and future growth, giving us a really solid, reliable requirement of 30 cores.
Let's pivot and think about storage for a second. I've got a question for you. We have those 20,000 routers, right? Now, let's conservatively say every single one of those routers generates about 50 megabytes of syslog data per day. Over a single year, how much raw storage do you think that actually requires?
It is a massive 365 terabytes. Just imagine stocking up 365 heavy-duty enterprise hard drives just to hold plain text logs. And honestly, that's just the baseline. If your business suddenly pivots and requires telemetry data to be collected every single second instead of every 5 minutes, this number easily balloons into the petabyte range. This right here is why planning is so absolutely vital.
And that brilliantly illustrates our next core resource, the network itself. If you calculate the average traffic for those routers, it might honestly only sit around 7 megabytes per second. But averages are incredibly dangerous in capacity planning. In the real world, a major network event is going to cause peak spikes that demand 10 to 20 times that baseline capacity. You can't just build for 7 megabits. You have to build 10 gigabit, 25 gigabit, or even 100 gigabit multipath networks just to survive those momentary spikes.
All right, Section 3, database and cluster sizing.
Now that we've got our core compute sorted, let's look at the data layer. Because let's face it, the database is almost always the very first thing to fall over under pressure. Say our system needs to handle 5,000 read queries per second and 1,000 write inserts per second. A single standalone database is going to become a massive bottleneck incredibly fast here. So true capacity planning at this layer means designing a strict read-write split, deploying read replicas, and actively partitioning and sharding your data. You have to distribute that load way before the bottleneck even has a chance to form.
Section 4. The golden planning formula. This is the pivotal moment, the mathematical heart of professional capacity planning. Every great architect relies on some variation of this golden formula. It goes like this. Future capacity equals current usage times your growth rate times a safety factor. It is brilliantly simple, but honestly incredibly effective. Let's say your baseline current usage is 100. If you anticipate, 30% business growth, your growth rate is 1.3. Then you add a 50% safety factor, so that's 1.5. So 100 times 1.3 times 1.5 gives you a rock-solid capacity target of 195. This exact formula is how architects guarantee stability. No guesswork required.
Which brings us to Section 5, Real-World Architecture Case.
Okay, let's actually apply this and build something tangible. We're going to use everything we've calculated so far to design a real-world Kubernetes cluster for our 20,000 router system. Let's say all our previous math tells us our total enterprise demand is 320 CPU cores and 1 terabyte of RAM. Well, if we use standard enterprise servers that have 32 cores and 128 gigs of RAM each, simple division tells us we need exactly 10 worker nodes. But again, we're architects. We don't just provision exactly what we need. Nodes fail. Systems require rolling upgrades, so we add in our crucial safety margin, padding that final design to 13 to 15 worker nodes just to ensure absolute resilience.
Seeing it all laid out like this is honestly a thing of beauty. We now have a complete, resilient enterprise stack. We've got 12 to 15 Kubernetes workers doing the heavy computing, a 3-node Redis cluster for ultra-fast caching, and 3 to 5 Kafka brokers smoothly handling that massive stream of telemetry data. Throw in a primary and replica MariaDB setup for our relational data, and an impressive 6 to 10 node Elasticsearch cluster specifically sized to ingest and search all those millions of router logs. That right there is what a properly planned architecture looks like.
Finally, Section 6, the architect's true job.
A lot of people mistakenly believe that capacity planning is really just a calculator exercise, tallying up CPU needs and buying servers. But that couldn't be further from the truth. The real shift in your mindset happens when you realize your job is actually architecting for inevitable hardware failure. It's designing a system that doesn't just barely survive traffic peaks, but handles them effortlessly. It's implementing robust backup and disaster recovery strategies, all while simultaneously optimizing the total infrastructure cost so you aren't just burning business capital on idle machines.
You see, your true art as an architect is perfectly balancing 3 critical elements: business, technology, and risk. You're constantly acting as the bridge between them. You have to ensure that every single technological choice you make fundamentally mitigates operational risk, while at the exact same time fulfilling those overarching business goals. It's a constant, highly dynamic balancing act.
I really want to leave you with this defining thought. Capacity planning is never about just surviving today. It's about confidently predicting 3 to 5 years of growth. So take a hard look at the system you're building right now. If your business traffic literally tripled overnight, would your architecture hold strong, or would it completely crumble? Think about it. Thanks for joining me for this explainer today, and keep building for tomorrow.